Okay, so this is an extract from some of our code from the AiRaid project. What we have here is basically extracts from the EGL initialization. This is pretty much standard code for those who've done it before. Not all the stages are here, but just the most pertinent ones which I felt necessary to describe. Those who've done this before will know one of the main things you're going to need to do is actually get a handle to the native display, and we can make use of EGL get display to actually return the native display. The next thing which we're going to really need to do after that, we need to create a window surface. This is the surface to which we're going to draw our graphics. Now, the most important thing here is that the native window type, which is actually passed as the third argument to this, is a bada window. It's a bada window to which we're going to draw our graphics. And I'll show how we actually achieve the layering effect of having the live camera preview and the graphics drawn on top. Having created our window surface and obtained our native display, we then need to create a context. This is the context whereby we are actually trying to attempt to bind the window surface, the native display, and the graphics layer to which we're going to draw our graphics. The final step is to sort of combine it all together, and we use EGL make current to perform that. I won't go into the depths and details of what this method does, but the important thing is that the read and write surfaces are both the same, and we're combining that with the first argument, which is the native display. So I just wanted to put this in here to hopefully have some developers say, oh yes, I've seen that before, I've done that before, because we're doing it in a pretty much standard way. So how is actually the layered effect actually achieved within bada? Now we use a simple layered architecture. What we actually do, we have a form, which is the container for the overlay panel. An overlay panel is a bada control which allows us to render live video. So essentially what we have is a form onto which we superimpose an overlay panel. The overlay panel will render the live video. On top of that overlay panel, we then superimpose another panel, which is a standard bada panel control. And this is the layer to which we actually draw the graphics. So thereby, we're simply achieving this simple layered effect. A camera form, which is invisible to the user, the overlay panel, which renders the live video, and a panel, which is a simple graphics layer, which is the argument which was made in the EGL core, which I showed earlier on. So, how do we achieve this in code? If you've done any bada programming, this will look very familiar. If you've not, it will look very unfamiliar. What we need to do, we need to create a camera form. The form is going to have no special attributes. It's just going to be of style normal. And once we've created and constructed this camera form, we need to add control of that form to our application's frame. So get frame, add control allows you to pass the camera form's pointer to the application's frame. So the camera form is now associated with the application's frame. So that's the first layer of our layered architecture. What we need to do now is create an overlay panel. So the overlay panel is what allows us to render the live video. What is not shown in this construct is how we actually link the overlay panel to the camera initialization. That's not shown, but if you really want to see that, I have the entire code base here with me, and I can share that with you. But what we're doing here is we're creating the overlay panel, and I'm showing here that we're constructing it to be of this size. So the rectangle object is x, y, the width and depth. So we're making it full screen. And then once we have our overlay panel object, we can then add control of that to our camera form. So now we have form overlay panel. We then need to add the panel object. So here we create a new panel. We construct it to be the same size as the screen. And then we add control of the panel to the overlay panel. So now we have the full layered architecture of form, overlay panel, and then panel. As the panel is the top level of our layered architecture, we can add a touch event listener to this panel. Now, we need the touch event listener because when you're actually interacting with the game, you have to press the button on the hoover, which is a touch event. At the top of the screen, we have an options key, which allows you to enter in-game options to maybe turn off the sound or turn off the vibration. Again, another touch event. So as that's the top layer, we actually add a touch event listener to that. We pass with this pointer to this because that will require us to override a number of pure virtual methods to obtain touch events. So that is pretty much how we achieve the layered architecture for our game, and making use of the touch event listener, we can actually then pick up touch events when you're actually interacting with the game. Okay, this is pretty much the game engine, and a lot's actually going on in here. Essentially, the game engine is all modular and it fits together quite well. Each ghost is a game model, and we use the Power VR SDK for Imagination Technologies to load pod files which contains all the textures, the animation data, the lighting sources and so forth for each of the models. A game scene is an object which actually groups all the game models into a scene. So this game scene object is like a class which manages all the game models, so it knows what models are on the screen, how many are to appear at any one time. It keeps track of what's there, what you've actually captured, so what needs to be removed from the screen. So it manages all the various game models, all the models. The game trajectory engine. This is quite a key class because what this actually does, it manages the game models in a manner that it actually knows the path that each ghost has to take. So it's like, how can I describe? It manages the trajectory of each ghost, their spawn times. Because the game is 360 and you're playing it in pretty much this type of motion, this class basically spawns the ghosts in a 360 motion around you. It knows where they're traveling, so it manages that type of data.